I said, so quick, quick recap. We are pretty much done solubility product KSP के I told you कि एक तो ये important था कि it was only for saturated solutions. ठीक है, that's it. Uh, so only KSP is only applied to saturated solution. They are at equilibrium. कि उसके अंदर the compound ionic compound, ठीक है, it was only limited to ionic compound. The ionic compound was dissolving, but at the same time it was also recrystallizing. ठीक है, so it was in equilibrium and in saturated conditions. So Ksp was the Kc of this reversible reaction. So it was product concentration divided by reactant concentration. You don't write reactant concentration. क्यों? क्योंकि it's a solid. So that is taken as a constant. So you don't write it. So these were your KSP expressions. Okay, that's it. Achha, now you're going to get two questions on KSP. Uh, the first one, they're going to ask you to calculate KSP. So for example, so question number one. But KSP का वो expression पता है ना? Clear? Is this clear what the KSP expression is? That sodium sulfate dissolving, so it's sodium ion concentration squared, sulfate ion concentration divided by the reactant concentration, but it's a solid. You don't write that. Okay? Is this clear that how to write the KSP expression?
Yes, sir.
And then what is also important is that what does the KSP value indicate? That if you have a large KSP, that indicates that it's very soluble. Okay? So KSP large means large means very soluble. So that points to a substance that is very soluble. And similarly, KSP if it's small, so that indicates that the substance is not very soluble. It's going to produce very few ions. So you're going to get three types of questions. So the type one is calculate KSP. Given solubility of the substance of the ionic compound in saturated conditions. Okay, that's question type one. So for example, they'll tell you that if you have saturated calcium phosphate,
Sir, I have a question.
yes,
So, like by large, what does that range equal to?
no, it's all relative. It's like it's not. I mean, there's no borderline. It's just
Like
relative
compared to what? Like,
compared to other salts. That's it.
okay.
ठीक है, so it's there's going to be a like if I say NaCl is soluble, so there's a question compared to what? So you have to make a comparison with some other salt. ठीक है, so maybe compared to copper sulfate. Like what is the Ksp of copper sulfate? I don't know if Ksp value of copper sulfate. So is that copper sulfate? But I think that's copper sulfate. So let's say so that's Ksp value of copper sulfate. Uh, if you have NaCl, so Ksp is given in it's 36. Okay, that's a very positive value. That means it's very soluble. So you saw copper sulfate, right? Copper sulfate was not very soluble. It had a low Ksp value. Is that clear? So the first question, so they're given us the solubility of calcium phosphate. So this is calcium phosphate, and the solubility of calcium phosphate, solubility is how much of it dissolves. Solubility is sometimes given in grams per dm cube, or sometimes it's given in mole per dm cube. A lot of times it's given in gram per dm cube. So maybe they're going to say that it's 5 grams, but since it's very less soluble. So I'm just making this up. So let's say it's 5 gram in 1 dm cube. That's कम कर देते हैं. Let's say it's 1.5 grams per dm cube. ठीक है. And remember, it could be mole per dm cube. What I'm going to do is I'm going to convert it into concentration. How do you convert gram per dm cube to mole per dm cube?
Divide by is mr.
ठीक है. So you divide by mr. So 1.5 gram. Find out what the mr of this calcium phosphate is. You convert the mass into moles. So it's 40 times 3. That's 120. And PO4, that's 31 plus 16 times 4. That's 95 times 2. So I think, is that 310? Does anyone have a calculator? What do you get for this?
Yes, sir. 310.
नहीं, क्या है 1.5 divided by 310? What do you get?
4.84 multiplied by 10 to the minus 3.
4.84.
Multiplied by 10 to the minus 3.
So what I've done is I've converted the gram per dm cube into mole per dm cube. The solubility was given to me. Now I need to find Ksp. To find Ksp, what I need to do is I need to first write the expression, which is calcium phosphate dissolving. ठीक है, the solid is dissolving. So it's going to be under a saturated solution. It's going to be a reversible reaction. It's going to produce what? It's going to produce 3 calcium ions, and it will produce 2 phosphate ions, aqueous. So solubility is the salt. It's the amount of salt or the concentration of the salt that has dissolved. Okay, that is what solubility is. So it's the concentration of the salt. It's not the concentration of the ions. It's the concentration of the entire salt that has dissolved or become part of the solution. Okay, that is what solubility is. That this is the amount, or these are the moles that are dissolving. Okay. Now,
Yes.
so now the thing is, so this is 4.84. This is the amount of salt that is dissolved. So what would be the concentration of the ions? The concentration of the ions would be, if one calcium phosphate dissolves, it produces 3 calcium ions. So it's going to be 1:3, right? To multiply this by 3, the concentration of calcium ions would be 3 times 4.84 times 10 power minus 3. Is that clear?
Yes.
And the concentration of phosphate ions would be 2 times multiplied by 4.84 times 10 to the power minus 3. Can you tell me what the value is?
For calcium, it is 0.0145.
Again, what's the value for phosphate?
9.68 multiplied by 10 to the power minus 3.
The 0.00, okay, 9, okay, 9,
9.68 multiplied by 10 to the power minus 3.
okay, 968. So 0.00968, right? So is this idea clear that if they give you solubility, okay, the solubility is for the entire salt, that this is the amount of calcium phosphate that dissolves in the solution. It's not the concentration of the ions. So using that, you will be able to figure out the concentration of the ions that are going into the solution. So 4.84, so this would be 3 times more, and this would be 2 times more. So ye clear? Is the first part clear? Amna, is this clear? Bhagi Zaina, is this clear? Minahil, is this clear?
Yeah.
Yes, sir.
So that's your first part. Now what you're going to do is now you're going to plug these values into your Ksp expression. So your Ksp expression it's the calcium ion concentration, and that's squared, that's cubed, and it's the phosphate ion concentration, and that's going to be squared. So this is going to be what, 0.0145. and this is going to be 0.00968, and that's going to get squared. ठीक है, अब now try and find this out. What do you get for this?
2.856 multiplied by 10 to the power minus 10.
Multiplied by 10 power minus 10, right?
Yes.
And the unit is going to be what? It's going to be mole 5 dm minus 15, I think. It's concentration squared, concentration cubed into concentration squared. So concentration to the power 5. So that's going to be mole 5 dm minus 15. So that's type 1 of the question. That you'll be given the solubility and you will convert that solubility and you'll find the value of Ksp. ठीक है, is this clear? You clear? Type 1.
Yes, sir. Yeah.
So then question
The
type,
the number of moles also, the number of moles come as the powers?
yeah, just like, I mean, remember what happens in Kc. This is Kc of this equilibrium reaction, right?
Yeah.
So it's calcium ion concentration that's going to be cubed, phosphate ion concentration that's going to be squared, divided by this, which is a solid, so that's going to be taken as 1,
Hmm.
right?
Okay.
So that's question type 1. Question type 2 is you're going to do the reverse, which is they'll give you Ksp and you have to find solubility. So the second type of question is you're going to calculate solubility and given the Ksp value. ठीक है, that's what you're going to do. So I'm going to do the whole question in reverse now. So let's pick another salt. ठीक है, I'm going to make hypothetical values for that. So let's say I've got silver sulfate, and the Ksp of silver sulfate is given as it's given as let's say it's 5 times 10 to the power minus 12. ठीक है, that's and it's mole cube dm minus 9. So they've given me this. Now I have to figure out what the solubility is. So I'm going to write down the reaction, which is Ag2SO4 solid. It's dissolving. It's in equilibrium with its ions in saturated conditions. So it's going to produce two Ag plus 1 ions and it's going to produce one sulfate ion, aqueous. Now, I don't know what the solubility is at the moment. So let's say the solubility in mole per dm cube is X mole per dm cube. Like this is the amount of salt that dissolves. So the concentration of silver ions would be what? It's going to be double, right? It's going to be 2x mole per dm cube. Is this clear?
Yes, sir.
And the concentration of
Yes, sir.
sulfate ions would be X mole per dm cube. 1:1, right? So if X mole per dm cube of silver sulfate dissolves, you're going to get 2x silver ions and you're going to get 1x sulfate ions. So I can now write the Ksp expression in terms of X. It's what is the Ksp expression? It's silver ion concentration that's going to be squared and is minus 2x. Second, sulfate would be SO4 would be minus 2 concentration, right? Now, what is in terms of X? Silver ion concentration is what? 2x, and that's getting squared. And sulfate ion concentration is given as X, and that's power 1, right? So what do I have? If I'm going to get 4x cubed, right? Is this clear? Okay, 2x
Yes,
squared
sir.
is 2x squared is 4x squared into x, that's going to give you 4x cubed. And I know the value of this. What is the value of Ksp? That's given as 5 times 10 power minus 12. Now using this, I can figure out what x is. X was the solubility. I can figure out what x is. So it's going to be x cubed is equal to 5 times 10 power minus 12 divided by 4. And I'm going to cube root everything. So do a cube root. Now tell me what the answer is. What is X?
1.077 multiplied by 10 the power minus 4.
1.077 multiplied by 10 power minus 4. So that means this is the concentration of the salt that dissolves. That's what X is. In a saturated solution, this is the amount of salt that's going to dissolve, right? Ye clear? Is this clear to everyone?
Yes, sir.
Okay, so
Yes, sir.
two types of questions. There's a third type of question, which we'll deal with later. We'll do some past paper questions first with this. Opening the same worksheet. Okay, it had a lot of KSP questions in between. One second, where's Equilibria? Okay, so we're gonna look for KSP questions. One second. This is KA. Um, I said you don't get a lot of big questions on KSP. They're going to be very small questions on KSP. So just hold on a second. So this one is, nee, that's more about lattice energy. Nee, where are KSP question? Here's a KSP question. Okay, so here's a question. He says write the expression for the solubility of KSP for BaSO4, right? So BaSO4 dissolves solid. So the reaction is that it's going to dissolve and it's going to dissociate and it's going to produce one barium ion and one sulfate ion, right? And they're both going to be aqueous. So what is your Ksp expression? Ksp expression would be your concentration of barium ions, the product concentration, and sulfate ion concentration. That's it. Okay. Is this clear? That's your Ksp. Clear?
Yes, 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 sir.
Now, in the next part, he's saying that the Ksp is given. He says calculate the barium ion concentration in a saturated solution of BaSO4. Now, now that's the end. The Ksp is already known. We know what Ksp is. So first thing, barium ion concentration. He's asking for the barium ion concentration. So if I take that as X mole per dm cube, the sulfate ion concentration would be exactly the same. Well, it's going to be exactly the same, right? If BaSO4 dissolves, it's going to produce the same amount of barium ions and exactly the same amount of sulfate ion. Is that clear? So, well, clear?
Yes.
So my Ksp expression would be that this is the value is given. It's 1.3 times 10 power minus 10. The barium ion concentration is given as X, and the sulfate ion concentration is also X. So basically, it's X squared is equal to 1.3 times 10 power minus 10. All you need to do is, if you want to find X, you have to underroot it. Okay, what do you get if you underroot this?
1.14 multiplied by 10 the power minus 5.
So it's coming out to be 1.14 multiplied by 10 power minus
5.
5 mole per dm cube, which is a very small value, which means that barium sulfate is not really very soluble. It does not produce a lot of ions. Okay, is this clear? This one.
Yes, yes, sir.
Yes, sir.
I said then the next part is that uh, there's this question. He says that the Ksp of barium carbonate is not significantly higher than that for B. Both of them have a very low Ksp value. They're not very soluble. The Ksp for barium sulfate was 1.3 times 10 power minus 10, and the Ksp for barium carbonate is 5 times 10 power minus 10. Acha, the question, I'll read the question first so we can answer this one. He says barium ions are very poisonous. So patients with digestive tract problems are sometimes given an X-ray after they've swallowed a barium meal, consisting of a suspension of barium sulfate in water. The barium ions in a saturated solution of barium sulfate is too low to cause problems of toxicity. So they're injecting barium sulfate into patients. Why? Because the barium ions produced have a very low concentration, so they don't cause any problems with toxicity. Now, he says instead of using barium sulfate, you could also use barium carbonate because that also has a very low Ksp value. So it's not going to produce a lot of barium ions in the solution. The idea clear? Okay, barium ion concentration is low, right?
Yeah.
But he says that barium carbonate is very poisonous if ingested. Suggest a reason why this might be so.
सर वो HCl के साथ रिएक्ट करके आई थिंक कार्बन डाइऑक्साइड ज्यादा बनाएगा.
Because your stomach has HCl in it, okay? It's got acid in it. So what happens is that when barium carbonate reacts and the stomach has HCl in it, remember that carbonates and HCl they react, acids react. So the barium carbonate will get converted into barium chloride plus water plus carbon dioxide. Now, if you remember solubility, is barium chloride a very soluble compound or an insoluble compound?
Insoluble.
नहीं chlorides में क्या था? What was the solubility of chlorides? The solubility of chlorides was that
Solvent.
they were all soluble except silver and lead chlorides. They were not very soluble. So barium chloride is very soluble. Okay, so the reason it's very poisonous is because barium chloride will dissociate a lot. It will dissolve a lot and it will produce a lot of barium ions and Cl ions in the solution, and barium ions were poisonous. Okay, so it's going to produce a lot of barium ions. So which is why it's going to cause problems with toxicity. Okay. So this is what you're going to write. You're going to write that it will react with the acid in the stomach and it will form barium chloride, which is very soluble and it dissociates and produces a lot of barium ions. Okay. Is this part clear?
Yes, sir.
I said, ठीक है सारू Zaina, is this clear? Everyone else, Zohair, clear?
Yes, sir.
I say you got this other one. He says write an expression for it's kind of the same thing. Write an expression for Ksp of MgOH2. So you're going to take MgOH2 and it will dissolve. It will produce Mg ions and it will produce two OH ions. What is the Ksp expression? The Ksp expression would be Mg ion concentration, and that's going to be power 1, and OH ion concentration, and that's going to be squared. Now he says the numerical value for Ksp is 2 times. So calculate it's kind of the same question. Mg2 plus concentration. So I'm going to take the Mg2 plus concentration as I'm going to take it as X. Okay, that's going to be taken as X. The OH ion concentration would then be double that. It's going to be 2x. Okay, because if 1 Mg is formed, 2 OH ions are formed. So if x mole per dm cube, this is going to be 2x mole per dm cube. I'm going to plug these values into my Ksp expression over here. So my Ksp expression would be, it will be the Mg ion concentration multiplied by the OH ion concentration, which is 2x, and that's going to get squared. So that gives me 4x cubed, and that's equal to the Ksp, which is 2 times 10 to the power minus 11. We're going to find what x is. So x will be 2 divided by 4 times 10 power minus 11 and cube root. ठीक है, what do we get?
One 1.709 multiplied by 10 the power minus 4.
1.709.
1.7099.
71, let's make it 1.71. And 10 power minus 5, right?
4.
So 4 mole per dm cube. ठीक है, is this clear? This one.
Yes.
अच्छा, so let's here's another Ksp question, the silver sulfate one. He says calculate the Ksp value for silver sulfate. So the Ksp expression would be it will dissolve, it will produce silver ions, 2 silver ions and 1 sulfate ion. So the expression would be silver ion concentration, that's going to be squared. And sulfate ion concentration, and that's going to be power. That's going to be power 1. What is the unit? It's going to be concentration squared. times concentration. So क्या होगा? That's going to be mole concentration cubed. So that's mole cubed dA minus I. ठीक है? Is this clear?
Yes.
So now over here, they found the silver ion concentration. He says that the silver ion concentration in a saturated solution is 1.6 times 10 power minus. So if you know the concentration of silver ions, that's 1.6 times kitna? 10 power minus. That's 10 to the power minus 2, right? The sulfate concentration would be half of that. So what is half of that? That's going to be zero point 0.8 times 10 to the power minus 2, right? Is this clear?
Yes, sir.
And I'm gonna plug these values into the expression. So it's 1.6 times 10 to the power minus 2 concentration squared into sulfate ion concentration, which is 0.8 times 10 to the power minus 2. So what do we get?
Two 2.048 multiplied 10 to the power minus 6.
Is that 2.048
048
multiplied by 10 power minus
6.
6, and that's mole cubed and dm minus 9. ठीक है? Is this clear? KSP.
Yes.
Yes, sir.
ठीक है, everyone else, is this clear? मेरा हेल्थ
Yes.
clear है? बाकी.
Yes.
Okay, so that's KSP. Now there's a third question. ठीक है, the third type of question is that's known as the common ion effect. Now, what the common ion effect is that, I mean, this is what the common ion effect is that if I try to dissolve, like I'm trying to dissolve silver sulfate, right? I say, remember KSP, just like Kc, its value does not change. The only thing that changes the value is temperature. So I'm trying to dissolve silver sulfate, and it dissolves and it produces silver ions in the solution, two silver ions, aqueous, and it produces sulfate ions, aqueous. It's not very soluble, so it's going to produce very few silver ions, very few sulfate ions. Now, you've got the solution, and the solution has silver ions and sulfate ions. Now, if I add a compound like sodium sulfate, now Na2SO4, the same solution, I'm adding another salt to the same solution. That other salt, if it's got a common ion, it will affect this equilibrium. Now, sodium sulfate is very soluble. So what two ions would be produced by sodium sulfate? Let's say I add a tiny amount of sodium sulfate. Like it's not saturated, so all of it dissolves. So it produces two sodium ions and it produces sulfate ions, right? So what has now happened? That all of a sudden in your solution, you've got a lot more sulfate ions. The concentration of sulfate ions has gone up. So if the concentration of sulfate ions increases, right? Because you're adding sodium sulfate, so there's more sulfate ions coming from sodium sulfate as well. So where would this equilibrium shift? Backward or forward?
Forward.
If sulfate ion concentration increases,
Oh, backwards. Yeah.
ठीक है, it's going to go backwards, right? But is that part clear?
Yes.
So it's going to go backwards, right? And as it's going backwards, right, sulfate ion concentration decreases, goes backwards. So silver sulfate would be even less soluble. ठीक है? So due to presence of common ion, which in this case is sulfate, the concentration of sulfate ions increases. So you have a lot higher concentration of sulfate ions, and the equilibrium shifts backwards.
The second equation is not an equilibrium.
No, I just added a small amount of sodium sulfate, so all of it dissolved.
Okay.
Okay. So the second one is not, I didn't add a lot of sodium sulfate, I just added a tiny amount of sodium sulfate, and all of it dissolved. Okay. So the equilibrium shifts backwards, and solubility of silver sulfate decreases. So what that does is it kind of promotes crystallization. Okay. For example, if silver sulfate crystals were not getting formed, you can add a bit of a tiny amount of sulfate ions coming from some other place. You can increase the concentration, you can send this equilibrium backwards, and more crystals will get formed. Do you understand the point? ठीक है,
Yes, sir.
you clear? अच्छा, now the same thing. You can have a numerical question on this as well. ठीक है? And remember, you have to always, when you're answering this, you always use this term common ion effect. ठीक है? There's a mark for that. So you're not just going to write the explanation, you're going to write that it's due to common ion effect, which is uh, that the concentration of sulfate ion increases and the equilibrium shifts backwards. I said, now, how would the question look like? We did silver sulfate over here, right? I told you, so I'm going to continue from here. Now, the Ksp of pure silver sulfate, the Ksp value does not change. It's 5 times 10 power minus 12. In reality, it's probably not that bad. Let's assume it's 5 times 10 power minus 12. So when you had pure silver sulfate, uh, the value of